everyone. My name is Harish Mandhadi, and I'm an enterprise technologist at AWS. So today we'll be talking about reimagining the future of development, which is AI-driven development lifecycle. So you might have heard a lot about software-driven development lifecycle, but today we'll be talking about AI-driven development lifecycle because of a lot of things changing within the technology in the AI space. So we'll be talking a little bit more on that. So this is the agenda today. So we'll be talking about how AI is disrupting the development. So what is working and what is not working. And we'll be talking about some of the methodologies around the AI-driven development lifecycle. And we'll share some of the new methodologies, which is reimagined, which is different from the software development lifecycle. So we have to talk about that. And we'll share some of the critical lessons learned that we have seen across adopting this AI DLC across many enterprise customers. So we'll share some of those critical lessons and also the important question, how do you measure the effectiveness using this methodology? So a lot of leaders might be asking, we have been using these technologies and the coding assistant, but how do you measure the success? How do you measure the productivity? So we'll be talking a little bit more about that. And I'll share some of those resources at the end so that you guys can take this ADLC methodology and try to incorporate into your day-to-day life, what you have been using. So we'll talk about that as well. So let's talk about how AI is disrupting the development. So there's a lot of stuff happening within this space, especially like a lot of tools coming every week and a lot of models coming every week. How engineers should be prepared. So there is a lot of confusion around this space, especially when you're talking to different personas. For example, if you're talking to an engineer, they'll be asking like they understand that AI is disrupting the development, but how should they be training? Should they be doing some kind of upskilling, or should they be doing some additional trainings of what they have been doing, or should they be pivoting what they have been doing and try to do something else because of the changing technology? And if you're talking to the leaders, some executives or some of the organization leaders, and they wanted to make sure they wanted to make their teams AI native. So what does that mean to be AI native? So we'll share some of those insights around like what we have seen by working with different customers across this space, especially adopting the AI DLC. So we'll talk about that. So like I mentioned, like a lot of things are throwing at us, and how as an engineer, you should be prepared for it, right? Like I mentioned, should you be doing some kind of upskilling, or do you have to follow something different, what you have been following around those? There is a misnomer that like whenever we use AI, things get faster, right? But this is one of the non-profit organization, which is meter.org. You can refer the paper. So they have conducted a real experiment, right? What they did was, so they took 16 open source developers, which is split into two teams. The first team has an access to LLMs. The second team has an access to no LLMs, which means that the first team has an access to new tools that's going on around the world. And the experiment was pretty interesting. What happens after conducting the episode? They were given the same kind of like a problem statements, which is like almost 250 problems, which is given to the same teams. And one of the other thing, and they were asked, the first team, which has an access to LLMs, they were asked like, what could be the productivity that they have seen using the LLMs? And the answer that came out to be like they predicted, they felt like they are 20% more productive when using LLMs. But after completing the experiment, and they have found that the team which doesn't have an access to LLM is 20% more productive than the team which has an access to LLM. That sounds very interesting, because does that mean that AI is not working in this space? What does that mean for us? So this experiment says it's not that AI is not working, it's a methodology that where we are using AI is not working. In fact, it's not the technology, but it's a methodology, right? So you can take a look at this particular experiment. It's pretty interesting. You can take a look at it. And let's talk about why AI is not working, right? So today, developers or any engineers use coding tools in two ways. One is AI managed way, which is AI builds the software end to end with least amount of human interaction or no amount of human interaction. In this case, AI builds the software, but it takes a lot of assumptions on behalf of humans. Humans are not kept in the loop, and they don't have any kind of validations or assumptions, because all the assumptions has made by AI, and AI generates ton of codes, and which is thrown back to the engineer, and they're not confident to take that code and try to put their name when they wanted to push the code into the production. And that's where you're not seeing, if you use this kind of like methodology, which is AI fully managed, but you're not seeing the productivity improvement that your organization wanted to see. Because like I mentioned, the like I mentioned, the engineers are not confident enough, because a lot of code is thrown at them and they are not confident because the validations and assumptions are not made by humans. So that's why they're not confident to. So that's why you will not be seeing some kind of paradigm leap of productivity. But this kind of like a method rarely works. Maybe it works for prototyping, like maybe a POC, but not a production grade systems. Then there's another approach, which is AI assisted way. This is the second method where a lot of engineers will be using AI in some fashion, which is AI assisted way, where in this particular methodology, what we do is, so we have been doing the same thing, which is the agile practices in the software development, like saying, where humans will do a lot of planning, which is creation of user stories or whatever that is. So we'll be doing same thing, but we'll be using AI in a very narrow and tactical way, maybe in some kind of very specific use cases. In this case, it's completely opposite to the approach one, but you might not see a paradigm leap of productivity, but you can see some kind of like a step increments of productivity, which is better than the AI managed way. But still, it is not enough for the organizations to have a great amount of productivity. So that's where, like, how do we achieve a paradigm leap of productivity rather than a step increment, which we saw in the AI assisted way, while keeping humans in the control? In the first way, which is AI managed, humans are not kept in the control. So that's why like they are not confident to push the code. So how do we achieve this kind of like a paradigm leap? We'll talk about that. So this is where we have like the new buzzword, which is the AI-driven development lifecycle, which sits in between the AI managed, where AI is not fully controllable, and it also sits an AI-assisted way where you can take the step increments. So it sits in between them and takes the best of both worlds. So that's where AI-driven. So typically, if you have to say in a simple words, as an engineer, you prompt an AI to do certain things for you. But what this methodology does is it prompts humans to think the plan that it created, right? As a humans, you need to have an intent or maybe a business case. But then once you provide that business case to the AI coding tools, then it comes up with a plan. Maybe it comes up with a design document or requirement analysis and all sorts of those things. Then you as a human needs to be in loop and needs to validate what it created for you. So that's where you need to keep constantly in loop in order to make sure these kind of like a practices in place and leverage AI as an orchestrator. So as you provide intent more, it tries to break down tasks for you so that you don't have to do, if you are in the product managers, so you don't have to create a user stories, but it can create for you, but your job is to validate, course correct what it came up with, and try to provide more information and context to it so that it learns on different personas, whether it's a product manager, whether it's a business leader or the security folks from the security team or the engineer or the operations team. So everyone gets together and try to come up with this methodology. So this methodology has two core principles, which is the operating model for AI and the operating model for humans, right? So like I mentioned, it's like a flywheel where humans have an intent and takes that intent and tries to create a plan, and humans verify the plan again, what that it came up with. Then humans, once verified, then AI refines the plan based on the suggestions that we provide. It then executes the plan and humans verify the outcome. It's like a flywheel methodology where you want to put humans at the center of what AI is generating and try to course correct every time. So this is the operating model for AI. And there's an operating model for humans as well. So a lot of people think getting code faster means like trying to push the products into the market faster. So where does time goes into SDLC? I think we all can agree a lot of time goes into meetings, maybe depending upon, I see some nodding heads here, which they agree with. Unfortunately, that's the reality, but no one talks about it. It's not that you can generate the code within 30 minutes, but that doesn't mean anything if you're not pushing the code to a production, right? In fact, like everyone just waits for everyone. For example, if you have a team of product team, developers will be waiting for the product team to come up with the user stories, right? And maybe the operations team might be waiting for the developer team to push the code and release into the production. Or maybe even the security team within the team wants to have some kind of like a threat analysis before running into the production. So it's like a cyclic dependency that we created, unknowingly or knowingly we created that cyclic dependency. So everyone just waits for everyone here. So how do you break this kind of like a cycle? Because writing code faster doesn't mean that you're shipping the products faster, features faster, right? So you need to solve some bigger problem, which is the human problem and the dependency problem, for which we have a operating model for humans. This is the new reimagined way. So there are a couple of methodologies here, which is mob elaboration. So what it does is we have to solve this problem of human dependencies, right? So how do you solve the problem? Going forward, the sprints will not be 2 weeks or 4 weeks. It will be maybe a day or 4 hours going forward. So how do you make sure you have these dependencies, but also try to achieve your sprint timing in less time? So the mob elaboration it's a new methodology which is reimagined in AIDLC, which is AI-driven development lifecycle. What it does is you try to bring different cross-collaboration team members, maybe product team member or maybe a business team member. Try to grab everyone into a single room for a 1 day or maybe a 4 hours of session. And maybe, like I mentioned, try to leverage AIDLC, which is instead of you prompting and doing a vibe coding isolated, we try to include people and collaborate across, because humans work better when they are together. So a lot of things, for example, if there's a dependency on certain team member and you have emailed them that I need this, and if they don't respond maybe like until next day, then you are blocked for the next 2 days, maybe 1 day, right? So how do you solve this kind of like a problem where we are trying to keep humans in synchronized and make sure everyone is together? So this mob elaboration, what it does is you bring all the stakeholders from business, product team, developers, and operations, and even the security team, right? Everyone to put together, and everyone has a common understanding of what they wanted to build, right? You have a business case or you have an intent, then you try to put that intent and ask AI to create a plan for you. Then every department will validate that plan depending upon each persona, right? Like for example, security can just say, hey, I need this kind of thing in the security forum. Or business can say, hey, I need this kind of like KPIs to meet. Or product can come up with the different user stories or the personas to put into that. So everyone has an input to say. So this is not even writing a code. So we are doing this way before writing a code. So we are doing a left shift environment here where everyone is like aligning to a common goal rather than just trying to ask AI to get the code faster to us so that we don't have a confidence. So that's mob elaboration. And the outcome of this is a validated vision. So if you think AI has a brain and humans, we all have a brain as well, this mob elaboration is trying to align both the brains together so that humans have control, but also AI is trying to help you in the way. So the outcome of this particular methodology is the validated vision that everyone is on the same page, but also you have a units of work which is split from this kind of like exercise. The next thing is, once you have a validated vision of the common goal, everyone has a common goal and everyone has put their inputs into it. Now we have a construction phase. This is where you are trying to build the production assets, which is development or maybe a coding or maybe a security standards that you want to build. So this is all happening. You're taking that units of chunks of work and try to divide them into multiple teams together, just like you see on the screen. So every team is like jamming here. Basically, what you do here is take that units of work and try to come up with units of work, and the code is created, generated, validated, and tested by the engineers, the security team, everyone. Now, after this, the outcome of this mob construction, you will have a production grade assets, which is trusted by engineers, which is validated by the product, every persona, right? So now you'll be super confident about the code that it's spitting, because you have a definition of done, which is validated by humans, but not the AI. Hopefully that makes sense. So if you try to put together a complete cycle, what we just spoke about, did I lost the screen? Yeah, I think I can, I'm back. All right. Sorry about the interruption. So if you try to put everything together, this is the full cycle, right? So in the inception, so this methodology has 3 phases, which is inception, where you did like a brain-to-brain alignment. Everyone is on the same page and have a common goal through mob elaboration by bringing people together in a single room and try to come up with a validated vision. Then once you have the validated vision, then you have a construction phase where you try to break down that units of work and try to come up with the production grade assets, which is validated and tested by your engineering team. Then once it is constructed, then it's an operation phase where you have a CI/CD and then the incident management. So that's how it's a full circle, and it's a mental model that we are following. And we have worked with a lot of engineering teams across enterprise customers and almost 400 to 500 customers where we adopted this kind of like a principle, and they have seen a productivity leap of like maybe 60 to 70%. In pre-agile, pre-AI era, that was like around 30%. So we're now accelerating this development productivity and using this methodology here. So I spoke a lot of things here, right? I want to put all these concepts and try to put into this methodology, which is a workflow. So we have tried whatever this conceptual information and try to put them into a coding rules. So you can, I'll share at the end of the presentation, which is an open source version where you take those bunch of rules which we codified, this whatever that we just spoke for the last 15 minutes, which is inception phase, construction phase, and operation phase, where everything is codified into a bunch of prompts. You can leverage and you can import those prompts into any coding tool that you have been using. For example, if you're using Kiro, or if you're using Cloud Code, if you're using Cursor, anything, it's irrespective of it. It has an open source version. You take those bunch of rules and try to import that into your repository of your choice. And then automatically, this bunch of rules will start analyzing your code base, whether it's a new project or if it's a brownfield project. It depends upon, like, it detects everything, and then it's an adaptive phase. If you have something like a new feature, then it has to go through all these phases. And if it's a bug fix, it doesn't have to go through all these phases. So a lot of people might be thinking this kind of like a new methodology works really well with the Greenfield. For those who don't know about the Greenfield is something that you are building something new. Brownfield is something that you might have already built and you're trying to make more features into it. So for the Greenfield, it is pretty straightforward. You use this ADLC workflows, and pretty straightforward. You wanted to achieve that, but it's challenging in the Brownfield environment. So you need to make sure you are helping AI to understand your code base. So treat AI as your intern. Like when you're joining a new organization, how do you feel about getting into the code base? Treat something like that. So in case of Brownfield, make sure you help your AI to understand how your existing code base is. So you can do that. And this particular workflow that I've been talking about will analyze and detect your existing workflow and come up with the techniques called reverse engineering techniques or call graphs. It tries to analyze these different patterns within your code base and try to come up with something. But at the end, you as a human or whoever has the knowledge about this particular product needs to validate that. So that's how we can make sure it works with brownfield customers, and we have a lot of success with brownfield customers as well. But we just need humans' input in those kind of modernization, and especially like this particular brownfield situation, modernization is one of the top use cases that we saw working, because we might have a lot of legacy code. Previously, there is an inertia that everyone has to touch about the legacy code, because the one who coded this particular legacy code might have not been with the company and they don't want to touch. Everyone is just like scared about this particular old code and they don't want to do anything. So we keep on patching the existing code base, which becomes a kind of, it's unchangeable. But with this kind of a methodology, there are some techniques which is inbuilt in the code that I'll be sharing at the end, where it has reverse engineering techniques, call graphs, and dependency mappings, where you can use those methodology and try to analyze your code base and try to rewrite it using the coding tools that we have at this moment. So that's one of the top use cases that we see. Some of the lessons learned during this process when we are doing this kind of like a workshops with a lot of enterprise customers. So these are not a gold standard per se, but these are some of the important things that we thought we wanted to make sure you guys are aware of it, because this helps us to make sure we have a good amount of productivity paradigm in terms of realizing the changes. So the first one, let's talk about the vibe coding. So vibe coding is very isolated. I think most of you will agree, but think beyond vibe coding and try to make sure like you collaborate. That's how like you will be seeing great amount of productivity leap. Otherwise, it's at the end, you're just making sure you're trying to wipe code, but it will be a step increment. But if you want your organizations to make sure we have a big impact, you just need to touch every department within this SDLC, which is not just the coding part. You can just write the code in 30 minutes or maybe in 2 hours. But if the rest of the organization is not equipped with same kind of like velocity, you just build the backlog of development, right? Which is not good. The second thing is maximize semantics to token ratio. This is very important. So when you're trying, I think there are some speakers who talked about context engineering, which mimics something similar. So more context doesn't mean that it's good always. Sometimes it's really bad for you. It might confuse your AI. So more context doesn't mean that it's good for every use cases. Make sure the context that you have put in place is relevant or not, right? You keep on testing whether whatever that you're building at that point of time, you have the right context at the moment or not. If you don't have the right context, try to trim it. So with the new coding tools that we have, everyone provides the context what's sitting out there. So refresh, rebuild the context very strategically so that it tries to help you. You need to help your AI so that it helps you in order to achieve your goal. And coming to semantics to token ratio, you can ask certain things in same way, but try to ask in a more meaningful way. For example, if my application wants to be more resilient, or maybe I wanted to incorporate a circuit breaker pattern using exponential backup. This is a traditional resilience model that is more rich in context and meaning. So you just wanted to have those kind of like a context set which has high semantic meaning. Sorry, I'll have to rush a little bit. But one more important thing is, as I mentioned, refactor and rewriting is faster than patching because of the new techniques that we just discussed. So ultimately, if you're owning the code, your name will be on the check-in. So just make sure like you really understand the code that is spitting it out there. So you should be in a position to able to debug that code if you get a page in the middle of the night. So that's how you should be confident enough. So this is for the leaders. They wanted to measure the development outcomes of really how should we measure. We have been using the coding tools. It's not that number of lines accepted or number of lines generated. It's about how fast we are shipping the product. So that's how you need to measure the velocity. So velocity is very important. Like amount of time to ship the product is more important than number of lines accepted, which doesn't make sense. The quality is also goes hand in hand with the velocity. We just need to have a really good quality. Without having a great quality, velocity doesn't make sense. And the other important one, which is predictability. So the amount of time that we committed into a sprint versus the delivered, we just need to measure that so that you can average across your organizations so that you can see what's the productivity that you are seeing across your organization. And this is my last slide. So how do you measure the end-to-end delivery timelines? So don't overthink about how do you want to measure. Take something which is already in the backlog that you might have. Try to use this kind of like a methodology and try to see what kind of like productivity gains that you are getting. Whether it's a 2x, whether it's a 4x or 5x, you can have your own A/B comparison of what it is, and then you can come up with the persona, how your organizations are trying to embed it. So this is the resource. This is an open source. If you like to have a screenshot, take a screenshot. So this is where you have all the bunch of rules that you can take into the consideration and take those into any kind of like a coding tools, and you can import those. It is open source. By the way, you can also contribute that. And there's a white paper about what we talked about here. Yeah, that should be it from my side.
We have time for questions, if there's any.
Fine. So I'm from a pre-AI generation. For years and years, we have been agile methodology has been thrusted onto our mindsets. And you mentioned in AI-driven SDLC that you're reimagining it, and you don't want AI to be retrofitted into agile, right?
Yeah.
And that you want to have a brain-to-brain conversation between human and machine. So that was interesting. And I hope you could elaborate a little bit on that, or maybe you already did.
Do we have time or? Yeah. So basically coming to the retrofitting, keeping the humans in the loop. Right now, we have seen two methodologies, which is AI managed, where we don't have a control in what AI is generating, but we want to have a control in what AI is generating. So for example, you can just ask, build me an e-commerce website. So it has a lot of things. It has already trained a lot of in different areas. For example, in logging, authentication, do you need those kind of like information? So you need to have those control whether what I need rather than what AI is trying to provide me. So in that case, like you need to have this control, and that's how like you need to have this brain alignment with AI and the human so that everyone is on the same page. Does it make sense?
Like say, build the next Amazon, make no mistakes.
Yeah, exactly.
There's any other question?
Hey, so interesting paradigm. Now, you mentioned you want the human developer to be responsible for the code, and that's a fine concept.
Yeah.
But if you do this for 2 years, where the AI is writing all the code and the human is writing less and less, they are going to become very rusty. They can measure the outputs. They can write smart tests. And then 2 years from now, you may even get to the point where is Java or Python really the most efficient language for one AI agent to communicate with another AI agent? Or will it, Andre Karpas, will it go the way of assembly language where you are just writing the English outputs?
Yeah. So that's a very interesting point, right? Like, I think it's already there. So if you go to the Anthropic, they're not even writing a code. They're communicating. I think I cannot predict the future, but I think that's the direction that we are going. So eventually it's going to be a plain English language. So you just need to put more thought in what you're asking and asking right questions. So it becomes the paradigm of asking the right questions rather than getting into the coding and something like that. But I think it's more about interacting, but having a tough conversation with an AI. It can be, yeah.
One more question. Oh,
So with the higher adoption of AI development lifecycle, what's going to happen with the human domain knowledge? Can it, like, over time, human be kicked out of the loop? And for AI to be biased at that point towards which tech stack to choose?
I think it becomes irrelevant at some point which tech stack, because AI will be training in every tech stack that is possible out there. But when it comes to human relevance, I think that's a bigger conversation. We might solve some bigger problems that we thought that we may not even solve. I think we're trying to get more problems solved than what used to be in the past. So that's how maybe we might use more humans in that space rather than, but eventually, if you look at 2 years back, the coding assistance has become tremendously rich compared to now, right? You just need to make sure you adapt. So I think one thing that we always talk with end customers is be curious to learn. I think that's the skill that we all wanted to adapt. Try to like learn with the new technologies that is coming out there and maybe solve some bigger problems that we have.
yeah. I think we're getting like a little bit of a speculative, like Terminator type of a scenario, right?
It's late.
Good talk. And yeah, round of applause. Do we have our next speaker?